Hello guys, today we'll be working on the circumcircle, which is what we're seeing here. Basically given 3 points, or a triangle, right? As long as we have 3 points, we want to find the circumcircle for those 3 points. Circumcircle is basically the circle which the outline passes on the 3 points. So that's the goal of today. This is not, well, it may be useful for you, but this is not useful on its own for right now. But it will be useful in a future sketch that we do for creating Delaunay's triangulation. So so basically you can find more information on the Wikipedia. There's multiple ways of finding a circle for 3 given points. I'll be showing you what I will be doing today. All right, so let me get a pen. Awesome. Okay, all right. So, given 3 points, right? So let's say we have our canvas right here, and we have first point, second point, and let's say third point, right? So to find the circumcircle, I need 2 lines to begin with, right? So first thing first, I need to figure out the center of that circumcircle. Once I find the center of it, I can just pick can get the distance from the center to any of the points that were given and get the radius and then draw a circle, right? So that's not an issue for the radius. The real thing that we need to figure out is the center point of that circle. So to get there, what I'll be doing is for 2 given edges of the triangle, right? So let's take this one, for example. Let me draw a line. All right, let's call this one, let's call this one A, B, and C. Let's call this line C, and we'll get this line as well. Let's call this line B, lowercase. No, okay. And this one, let's just not care about it for right now. All right, so we have those 2 lines, right? So what I need is a perpendicular line for both of those, starting at the middle, right? So I need to figure out this point, and I need to figure out any point perpendicular to that line at that place, right? So let's take it here, for example. Here, for example, right? So, so this over here is the perpendicular line for A and B, right? And I need to do the same for C and A, right? The other line, and the other side of the triangle as well. So to get the perpendicular line for A and B, or for any 2 given points, right? For any points, right? Okay, so this will be a vector, this will be a vector, this point over here will be a vector, and this point will be also a vector. So we are first given 2 vectors, A and B, right? So A and B. Let's first get the midpoint, right? So the midpoint over here. So I'll call it mid, right? So midpoint. So the midpoint x value is going to be the lerp between the x of A and the x of B at 50%, right? We want the middle point of x, and then we'll do the same for y. So we can use lerp, or in this case, it would just be, I guess, the average, right? The mean, right? Well, in any case, let's use lerp. And then we'll pass, let's say, A dot x and B dot x. And now hopefully you can see. So this would be our, oh, and we need to pass the amount that we want to lerp. All right. So this will be the x value for the midpoint, and the y value will be the same thing. So it will be also lerp, but this time it'll be a dot y and b dot y at the same value, which is 50% or 0.5. All right, so this will be our midpoint. So we already know this point, right? This point over here, the midpoint of that line. Now we need to get this point. So let's first create a vertical line. Like, let's first take this line and turn it vertically, right? So we know A is a vector and B is a vector, right? We can create, because like we can create a new vector out of A and B, where it's going to be the same length for that line and everything, but it'll be expressed in one vector, as if the line was starting from here instead of A, right? So let's do that. So we can subtract, we can subtract from B, we can subtract A, right? This will give us the 0, 0 origin for the line, right? This line. So let's first do that, right? So let's call it what? From origin. Awesome. So from origin, we'll just use p vector's built-in function for subtracting and creating a new vector out of the subtracted values. So let's just do, it'll be p vector dot sub for subtract, and we'll sub from B, we'll subtract A. I don't think it really matters which one we subtract in this case, since we're going to get the 90 degrees value of it in any case. But let's do this, right? So we get this value. Awesome. Now, what do we do with it? We need to turn it 90 degree, right? So it's pointing, it's currently pointing down, right? We need to rotate it either this way or this way, 90 degree, right? In this case, it's pointing down, right? But it could be pointing sideways, and we would need to rotate it 90 degree, right? So in this direction or in this direction, right? So that's the goal. So we need to rotate it. We'll again use p vector's built-in function for rotating a given vector. So we'll do from origin. Let's do underscore here. So let me just erase this one. Okay, awesome. Okay, great. So we can directly rotate it from this one, right? Dot rotate, and we will do half pi, which we need to pass in the radian value of degree. So it'll be like, it won't be in degree, it won't be like from 0 to 360. So it won't be 90 degree that we put here, but well, it's going to be half pi, right? Like, actually, I'm going to put 90 degree here just so that it's easier to read on the board. All right, so we've rotated it, right? So here now it's going, let's say, this way, right? Since the previous one was going down, we added a 90 degree turn to it. Now it's going this way. Awesome. So we're almost there. But now we need to move it back from here back to here. So we can just add to this the midpoint, right? We want to move this point to here. So we just need to add it, right? So we can just do, I'll do dot. This dot is going here, but it doesn't matter. Dot add, and then mid. Awesome. So we already have the two segments, or the two vertices of the line. Awesome. Great. So what do we need next? Well, we do the same exact thing, but instead of A and B, we do it with C and A or A and C, whatever you want. So in the end, we get 4 vertices, right? We get, so in this case, it would be maybe, right? Midpoint would be over here, and it would go down, let's say, like this, right? So we have 4 vertices now, after doing it for both lines. We have this vertices, this one, and this one. And then we're pretty much done. The last thing we need to do is, so we need to find, we know now that this is the center of the circle, right? Visually, we know it, right? Well, maybe it's maybe not easy to see right now, but anyway, this should be the center of the circle, which is the intersection between the 2 lines that we just created. And that we can get from Wikipedia the formula to get the intersection point for 2 given line. Because yes, awesome. So we'll start with this, and then we'll look at the Wikipedia page for line intersection. Awesome. Let me get back to here. Okay, great. Let me remove this. Okay, let me start from fresh. This is not the same editor as I use normally. This is just IntelliJ. I mean, it doesn't matter. It's still processing Java. You can just use processing ID. It's totally fine. Awesome. So let's first create 3 random point on the canvas, right? So what I'll say is maybe we'll have like p vector. Well, no, let's just do it all at once, right? So and never mind settings. It's just that the size cannot be initialized and set up in here, but think as settings as just setting the size, right? There's other stuff, but it doesn't matter. So we have setup and draw. So that's the main functions that we want. All right, so let's create our 3 points, right? I'll call them A, B, and C, right? Sure, just like we had on the board. So let's do p vector a new p vector, and we wanted a random point on the canvas, so random between, for the x value between 0 and the width, and then the same thing but for the height, right? For the y, sorry. So random between 0 and height. Awesome. So let's duplicate this 3 times, well, 2 times, and then, oh, wait, no. Yeah, A, B, and C, right? Awesome. Okay. All right. So now I think I would like a function that return like the 2 vertices of one perpendicular line, right? Let's call it P1 and P2 for perpendicular lines. So let's call this perpendicular. Okay, and it'll receive 2 points, A and B, and let's say this again too. Say B and C, right? Doesn't matter. 2 points. Okay. So let's create that function perpendicular, and it will do exactly what we did on the board. So let's do that. Let me remove draw. I don't need it right now. Okay, so it'll return, so it's going to be a public function that returns an array of p vector. Well, an array of 2 specifically, p vectors. All right. It will also receive, let's call it A and B, right? It'll receive p vectors A and B. Awesome. I cannot type today. Awesome. All right, so we said first thing first, we need to figure out the midpoint of those 2 lines. So let's just get the midpoint. So let me do p vector. My God, p vector. Let's call it mid. Same thing as O there. And from origin doesn't make sense. I can just call it I'll just call it P for perpendicular. I don't know. Anyway, it doesn't matter. So it's going to be a new P vector, which, like we said, we want the lerp between a dot x, a dot y, b dot x, and then 50%. Oh yeah, and one floats. Okay, awesome. And then do it again, but this time it'll be for y, the y value. Y, awesome. Okay, so now let's call p vector. Let's call it p. Like I said, doesn't matter. So now we need to use p vector sub, right? P vector dot sub. And we said B, A. I don't think it matters again. It could be A, B. It's fine. We just want to rotate it in the end, and we want to keep the same vector length and vector orientation. No. Well, I get what I'm saying. Hopefully you do. But yeah, okay. All right. So then we need to rotate it since we want the 90 degree. And like I said, on the board I wrote 90 degree, but actually I'm going to use radians. So it's going to be half pi because pi is half a circle in terms of angle. 2 pi is a full circle and half pi is 90 degree. So a quarter of a circle. And then we need to add the midpoint to displace it back to where it needs to be. All right, we're pretty much done with perpendicular function. Let's just return the p-vector array, which will contain the midpoint and p, right? All right, so we have our two p-vectors. Awesome. Let's just draw them on the board. On the screen, right? So let's first draw the, well, yeah, sure. Okay, let me just think. Yeah, and they might not be in the orientation that I shown, right? Let me go back there. Okay, there you go. My 10 over here, right? I draw the line here, right? Going this way, but it's possible that we get a line that starts from here and goes up instead of going down, or going right instead of going left. But it doesn't matter because when we're going to compute the intersection point, it should be, it should figure out anyway. As long as we have 2 points on the line where we can figure it out. Okay. All right, but when I draw it like this, it might show the vectors going up, well, the lines going in the other direction than what we're like thinking visually. Let me just mute everything. Okay, awesome. Okay. So let's just draw them to start with. So stroke, let's do red for the perpendicular line. So maybe 220, 50 and 90. Okay, so some red. Let's do stroke weight of, I don't know, maybe 5, something like this. Sure, that's fine. So this is for these lines. I called it P, but not for points, for perpendicular. Maybe L is better for line. I don't know. Yeah, sure. Why not? And now let's do a line, and we'll do the follow-up line. So line 1 will be L1 index 0 dot x dot x, I said? Okay. L1 index 0 dot y, and then, yeah, sure. L1 index 1 dot x, and L1 index 1 dot y. Right? Yeah, I think that's it. Okay, let's draw both of the lines, but it'll be L2 in this case, L2, L2, and L2. Okay, And let's also draw the original lines, right? So let's draw them maybe black, sure. Stroke 0. Let's do 2 lines, and we know the 2 lines is going to be AB and BC. So A, B, B, and C, right? All right, let's just see if this shows what we're expecting it to. That's perfect. That's exactly what we wanted. Great. So now we're almost done. We just need to figure out the intersection point, right? Where's my mouse? Oh, over there, right? So this middle point, that's the point that we absolutely need to get to create the circumcircle. All right, so let's look at the Wikipedia. So line intersection, right? So that's exactly what I need. In the formula, if you just look down just a little bit, given 2 points on each line, that's exactly what we want. There you go. So this is what we want. Let me save the image. Sure. I don't know where I saved it, but it doesn't matter. Oh, it's an SVG. Oh, okay. Well, you know what? Let me move this over there. There we go. Let me put this on the right. Okay, and this on the left. Okay, great. Awesome. Okay, so let's create a function called intersection, right? Just so that it's not messy wherever we're doing our stuff. So let's do public p vector, which that's what it's going to return. Intersection, sure, and it's going to receive um, 2 lines. So p vector, like an array of 2 for the first line, and an array of 2 vector again for the second line. There we go. Awesome. Okay, and it's going to return a p vector. Return new p vector xy. Sure, it's fine. So we need to figure out xy, right? So looking at it on the right, these are the formulas that we need. So let me just set, it's not needed, but I'll just do it for my sake, because when looking at it, it'll be like difficult to just figure it out. So let's just set the variables for like x1, x2, x3, x4, and y1, y2, y3, or y4. Let's just so it's easier afterwards to look at both and just compare, since there's a lot of variables and the formula is pretty long. So so x1 will be a0.x, and then float y1 will be same thing but dot y. Awesome. Let's copy this, paste this here. Then it'll be 1, 1. It'll be 2. Let's copy this whole thing, and then it'll be, this will be the same. This will be b, 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 and b. Okay, and this will be 4, 4, 3, and 3. Okay, great. So we have all of our variables that we need. So we'll have a float x at the end, and we'll have a float y at the end, right? So in their case, it's px and py, right? So point x and point y. Okay, so what I'm seeing here, what I notice is that both denominators are exactly the same, right? So this line over here and this one over here are exactly the same. So I'm going to create a variable for the denominator itself, since writing it twice, it doesn't do anything for me. Denominator, I think, right? Is it written like that? Denominator. Oh yeah, it's right over there. I didn't see it. Okay. In our case, I'm not expecting in any time that the denominator is going to be 0, right? There should never be parallel lines for the circle, right? So for the perpendicular lines crossing the circle. So I'm never expecting the denominator to be 0. So let's do it, right? Let's write the denominator. So it's going to be x1 minus x2 times y3 minus y4 minus y1 minus y2, right? Yeah, nice. Times x3 minus x4. Okay, great. So we have the denominator done now. So we know there's going to be something here divided by denominator, right? It's going to be the same for y. So let's get those done, right? So let me just do it on a separate line, and afterwards we can just put it back on the same line. All right, so we'll have first parentheses times second parentheses, well, times second parentheses minus third parentheses times fourth parentheses. Let's first start with that. Okay, so the first one, x1 times y2 minus y1 times x2. Okay, great. So first parentheses done already. x3 minus x4. Okay, great, done. And then x1 minus x2. Yeah, okay, great. Let me just because my head otherwise not going to like it. And then x3 times y4 minus, whoa, y4 minus y3 times x4. Okay, there we go. So we're done with the x. Great. Let me just format everything. Yeah, awesome. Okay, let's do the same thing for this one. So again, it's going to be the same exact kind of formula. Okay, great. Let's go to the first parentheses. So x1 minus times y2 and y1 times x2. Sorry, it's just difficult to keep track. Okay, right? y2, y1, oh, yeah, sure. Okay, and then y3 minus y4, and then y1 minus y2, and then x3 times y4 minus y3 times x4. I think we're done. I think we figured out missing 1%. Okay, great. I think we're done. Yeah, I think we pretty much got the intersection function done. So let's try it out. So let's maybe get p vector. Let's call it I for intersection. These are not great names, but I would suggest you setting better names for your variables. Right now, I'm just doing it, so it doesn't matter really. Let me calculate it over here, and let's keep all of the drawing at the same thing. Okay, so let's draw the intersection point as maybe some type of green. So stroke, some type of green. So let me do like 50, 200, and 100. Think it's going to be green. Hopefully it is. Let's do maybe a bigger stroke weight. Stroke weight, maybe 5 seems fine. And then let's do a point. We're almost done. I called it I, so I.x, I.y. Okay, great. So we're done with this. Let's try it out. Green is maybe not the best color, actually. Let me do much bigger, maybe 15, just so it's easier to see. It was there, but it was really small. Okay, there we go. So that's what I said regarding the red lines that we're seeing right now, the perpendicular lines, going in the other direction, but our formula for the intersection doesn't care about it. as long as eventually if you extend the lines, it crosses, it'll find that point, right? Which is the green one. Let me rerun it to see if we get just a better visual. No, again, rerun it again. I mean, this one, the points are really close to it, but it's going to be really far away, right? I'm guessing it's going to be somewhere which we don't see over here. It's going to be like a really large circle since the points are so close to each other. Let me retry it. I mean, damn, I had it good the first time on. Damn. Okay. I mean, let me try it again. Okay, that's fine. I mean, we can see that the intersection will be right here, right? So that's cool. So now we have the middle point. Well, the center point of the circumcircle. Now we need the radius. So float radius r. Like I said, name your variables a little bit better than mine. It's not the best, but I'm explaining it true, so it's fine. So r, the radius. We said we can calculate just the distance between any of the points, original points, and the center point. So let's just do that. There is a p-vector function for distance, calculating the distance that returns us a float. We need to pass it two p-vectors. So let's pass it a, for example. It doesn't matter which one we take from the first tree, as long as we take one of those. And let's take the center point, which for, in our case, it's I, right? So R is now the radius. Let's now draw the circle also. So maybe stroke, maybe blue, right? This time. I'm really not good with colors, but hopefully you're better than me with colors. Let's do 20, 50, and 220. And stroke weight, let's put it back down because this is going to be just way too big for a stroke weight. Let's do 2. Sure, I think I'm fine with that. Let's do a circle. I could use ellipse, but I'll just use circle since it is. So the center point of our circle, I, and then the here circle, expect the diameter. So we'll use r times 2, which is the diameter. Let's run this and see if we see the circumcircle. Okay, let me draw this one first, so that it's not on top of everything else. And why? Oh, I was wondering why it's so thick, but it's just stroke weight. I didn't put weight on there. There you go. Oh, okay. Wait. Okay, cool. Let's retry that. Okay, a bit small. Let me do another one. Okay. Cool. So we see this is the center point of the circle. Over here, we can see that if we were to extend this one, it would cross over here, right there. And then we just calculate the distance between any of the points of our triangle and the center point that we calculated from the intersections. Right, so we're pretty much done with the circumcircle. I'm not sure if there can be anything really cool to do with it. Just with the circumcircle? Probably there is. I'm just not imaginative enough to think of it. Hopefully you can. But yeah, so this was the whole sketch. This will be really useful in some future video where we do the Delaunay's triangulation, which will be based on this specific principle. So hopefully you enjoyed following along, and catch you in the next one. Thank you.